This is your normal sine graph. But right here you see y equals 3 sine pi over 2, 3 being your amplitude, which is your height above and below. You know, this is really boring.
This is extreme math.
Fresh Kid Z, Fresh Kid C, yes, sir. Fresh Kid P, Fresh Kid T. Oh yeah, we back. Oh, and Zafoon, by the way. Yeah.
Connor's distance from the green bush can be graphed as a cosine graph. In this picture of a cosine-like roller coaster, the red arrow equals the amplitude and the blue arrow represents the period. If we want to graph the distance the fruit traveled, and we consider that behind the camera equals negative distance, this last activity can show a tan graph.
So here is our sine graph made from paintball. As you can see, we have an amplitude of about 3 both ways. That's the normal amplitude. And there's a slight negative phase shift right here. Normal graph for this, not saying it's this one, would be like y equals 3 sine of pi over 2. And then if you were to put a negative in front of it all, you get this. Flip right upside down, normal sine, cosine, just start your highest point. Same
How to make the equations.
Cosine and sine are a lot alike. There is your amplitude, which is your highest or your lowest point from the x-axis. Except for cosine, you start at your highest point, making it where you go down or up, depending if it's negative or not. Right here is B and C for both of these. You use that to find the phase shift of negative B over C. And the last part is your vertical shift. You go up from the x-axis, and that's where your graph will actually start. Here you have the tan graph. The amplitude will not be used, but it's still going to be there. Then you use the pi over 2 plus 1, and you set it to equal to 0. That is how you're going to find your asymptotes. Once you get the answer, you add it to your period, and then you'll be able to find every single other asymptote there is.
And now for some review. This is a typical sine graph. The phase shift is -5, and the amplitude is 60. This is a typical cosine graph. Again, the phase shift is -5, and the amplitude is -20. This is a typical tan graph. There is no phase shift and the period is pi. The first vertical asymptote is at -pi over 2, and there is another asymptote every pi after this. And now for the equations. First is sine. In this sine equation, 3 is the amplitude, pi can be used to find the period, and 4, when divided by the negative b value, pi, can be used to find the phase shift. The cosine equation is the same as the sine equation, so now on to tan. In this tan equation, there is a negative in front of the equation, so it is flipped. The 2 is not used because in tan graphs, the amplitude does not apply to the actual graph. The pi, again, can be used to find the period, and again, when you use negative c over b, or 5 over negative pi, phase shift can be found. By setting the values in parentheses to 0, we can find the first vertical asymptote. After we find the first vertical asymptote, by adding the period to this value, we can find every vertical asymptote afterwards.